I will never look at a city skyline the same way after learning about EHV cables. Here's why. EHV cables, or extra-high voltage cables, are the unsung heroes of modern power transmission. They carry electricity at voltages above 66 kilovolts, sometimes going as high as 400 kilovolts. These cables are crucial for places where overhead lines just won't cut it. Think underground in cities or under the sea. An EHV cable has a lot going on inside. First, there's the conductor, often copper or aluminum, which carries the electrical current. Surrounding that is a conductor screen, helping distribute the electric field evenly. Then comes the insulation made of strong materials like XLPE to prevent electrical breakdown. Beyond that, there's an insulation screen to cut down on surface discharges. A metallic shield, usually copper, carries fault currents and reduces interference. Finally, an outer sheath and optional armor protect against the elements. There are different types: XLPE cables for stability, oil-filled for older systems, and gas-insulated cables filled with special gases like SF6. So why use EHV cables? They're space-efficient, reduce power losses, and are less visually intrusive. However, they're costly and tricky to install. Yet for underground city grids, subsea routes, and long-distance transmission, they're indispensable. Got a question about EHV cables? Drop it in the comments. When you look at a city skyline at night, the twinkling lights and the hum of activity are all powered by a complex network of electrical systems. At the heart of this network are EHV cables, silently doing their job. These cables are not just about transmitting power, they are about ensuring that power is delivered efficiently and reliably, no matter the distance or the obstacles in the way. Imagine a power plant generating electricity miles away from the city. The electricity generated needs to travel long distances to reach homes, businesses, and industries. This is where EHV cables come into play. They are designed to handle high voltages, ensuring that the power generated at the plant is transmitted with minimal losses over vast distances. The design and construction of EHV cables are a marvel of modern engineering. Electrical engineers spend countless hours designing these cables to ensure they can withstand the high voltages and the environmental conditions they will be exposed to. From the materials used to the layers of protection, every aspect of an EHV cable is meticulously planned and executed. Before an EHV cable is installed, it undergoes rigorous testing. High voltage tests, quality control checks, and environmental simulations are just a few of the tests these cables must pass. This ensures that once they are in place, they will perform reliably for years, if not decades. Installing EHV cables, especially in urban areas or underwater, is a complex and challenging task. It requires specialized equipment and skilled workers. The process can take months and sometimes even years, depending on the length and complexity of the route. But the end result is a robust and reliable power transmission system that can handle the demands of modern society. As we move towards a future powered by renewable energy sources like wind and solar, the role of EHV cables becomes even more critical. These renewable energy sources are often located far from the places where the power is needed. EHV cables ensure that the clean energy generated can be efficiently transmitted to cities and towns, reducing our reliance on fossil fuels and helping to combat climate change. In the future, as our cities become smarter and our power grids more advanced, the importance of EHV cables will only grow. They will be the backbone of our power infrastructure, enabling us to build a sustainable and resilient energy system. So the next time you look at a city skyline, remember the EHV cables working tirelessly behind the scenes to keep the lights on and the world moving forward.